So considering that you have appreciated the modules that comes into your system, then you need to be able to do scheduling. Each of these modules should be completed at what time. So that is why we are saying you need to be able to define the new system considering the implementation schedule. This is actually what I would also elaborate once I move to project management, a little bit on project management. We have an area known as IT project management, which actually deals with being able to manage IT projects. So, which fits well with defining new system and the implementation schedules. I want to display this like this. Now, information strategy planning. So IS planning applies system analysis methods to examine the business as a whole for purposes of defining overall plan and architecture for subsequent information system development. Remember, I said you can see that the deliverables within system analysis is at a stage of appreciating the IS development. You realize that the output is an architecture, which this architecture is now what we can use to schedule, do the other planning. So when I talk about IS strategy, the strategy applies analysis methods. Of course, we will be able to see system analysis methods in detail, but just to understand that IS planning or IS strategy planning applies system analysis method to examine the business as a whole, that is appreciating the entire organization for purposes of defining an overall plan and architecture for subsequent IS development, which is to be based on strategic plan. Business areas are needed to be carved out and prioritized, or what I can say, the sub areas or modules that makes up the overall system needs to be taken into consideration. So a business area is a collection of cross-organizational business processes that should be highly integrated to achieve the IS strategy plan or the business mission. So the different subsections, that's what we talk about. So principles of IS planning. So an IS planning is needed to support the firm's business strategy with appropriate technical architecture. So the aspect about IS planning is so that when I do an efficient analysis, I should be able to give a good architecture, a guideline that can be able to guide the development and subsequent implementation of an IS. So also this, in appreciating IS planning, again, these principles evaluate technology as a component of the larger system. Remember, I said, in any case of any information system, you need to appreciate information system as a collection of components, which marks the overall system. Also, we need to recognize the life cycle costs, not just acquisition costs, because at the end of the day, what you need to put into planning also is continuous use of the system. How will the system perform continually? That is why we would want to say the system is something that is part of an organization going forward. So we need to be able to recognize the life cycle costs of those systems, and not just one-time acquisition of those particular technology. So still again, under principles of IS planning, we need to take into consideration design information systems to be maintainable. And that is one of the key principles. Because at the end of the day, when you are developing an IS, make sure that you are able to develop a system in such a way that it can be extendable or it can be maintainable, so that you are not developing a system which can be phased out in case there is an incoming new technology. So you need to be able to develop, or having an approach in your mind when you are doing planning of your system, to be able to plan for maintenance. You also need to recognize the human side of technology use. This is one key area on human-computer interaction, which is also one area in IT which still under development on HCI, human-computer interaction, or what we sometimes would refer human factors in computing. So that you need to know how, you need to take into consideration how the users or customers are going to interact with the given technology. How will users perceive this system once it has been rolled out? That's why we are saying let interactivity be easier when users are going to use, or learning time when users are going to use this system. So as one of the principles, you need to recognize the human side of technology. You also need to support and control the technical system. Now, having seen planning, I want to appreciate resource management. Remember, I said we want to shed light on IS planning, resource management, and security. Those are the three things that we look into. So resource management, as it is, you have come across resource management before, which means efficient and effective allocation of organizational resources. So such resources may include financial, inventory, human skills, production resources, or information technology. So you need to do proper resourcing, considering that you have a number of resources. For example, in this diagram, you have seen you have system stakeholders, programmers, technical specialists, vendors, and suppliers. As a system analyst, or as someone who has been in a class of IS or MIS, remember, management information system, or IS in general, actually inculcates you the picture of having in a position, or having you in a position of a system analyst, who should be able to appreciate that you have different stakeholders coming in play when you're talking about the information system. So tomorrow you are in a position of doing or being able to manage the other stakeholders. You need to be able to appreciate that you have a number of people. And when you are developing an IS, you need to appreciate these people on how they are going to interact with this system. Sometimes you have vendors. How will vendors log into this system? How will technical specialists interact with this system, who are going to do support for the others? So in your mind, as a system analyst, you need to be picturing all these people at the same time. So there is also planning for competitive advantage, which involve analysis of potentials that the firm has using IT or IS over the others. Remember, I said in the inception of this unit, I must have said that in any case, why we are having IS is for purposes of gaining competitive advantage. And I told someone before that even if you're in a class of IS, at the end of the day, what you should be, even if you ask a question, why IS or anything, it is actually competitive advantage. Why we are learning this is so that also we will gain competitive advantage. So anyway, so planning for competitive advantage involve analysis of potential the firm has using IT or IS for competitive advantage. So you need to do an analysis of how your organization or your firm will gain competitive advantage over the others using IT or IS, and it is normally achieved considering the Porter's competitive advantage, or what we say achieved using Porter's competitive forces, which you must have learned before. You know what we mean by Porter's competitive forces, firm's competitive forces. You must have seen Porter's model, and you must know what are the competitive forces facing a firm. So Michael Porter competitive forces model provides a general view of firm and considering its competitors and the surrounding environment. So the 5 competitive forces shape the fate of a firm. How you are able to handle these determines your success as an organization. So also when you are implementing information system, you need to be able to look your IT and IS considering your traditional competitors. What technology are they using? For example, in the technology space at the moment, we are looking at issues like 5G. So if you are able to provide connectivity over 5G, then it means that those organizations which have not been able to migrate or able to adopt the 5G technology will not be able to leverage or take advantage of the technology. Therefore, I would say that they will not be able to gain competitive edge over your organization if you move faster to adopt this technology. So traditional, you need to look into traditional competitors. The new market entrants, what technology are they using? Substitute products and services, alternatives. For example, if customers, I would use a very good example of Safaricom and maybe Airtel. So what other substitute products or services that Safaricom offers, which makes Safaricom being preferred over Airtel by customers? So you need to be able to see what substitute products and services which you can bring in to entice customers, or other things that customers might use instead of your product. So you need to be able to be cognizant with that as soon as you are also looking at adopting or implementing a new technology. So you also need to focus to be customer centric and also supplier. So look keenly on that Michael Porter's competitive forces model. That is the diagrammatic appreciation of the same. So suppliers, I need to be wary of market entrants. What are these new entrants bringing into the market? So you need to be cognizant on what technology are these new entrants coming in with, so that you are not, they don't gain competitive edge over you. There's also substitute products. What are these other substitute products people might run into? Customers and even suppliers. So that's a diagrammatic representation of the same. So factors to consider when planning for new IS. As you have seen in the diagram, the environment in which the organization must function. Before I implement an IT or an IS, I need to check on the environment. For example, if it's a telecommunication company, definitely I would need to figure out the surrounding in terms of how will I be able to get internet, supply, and all those things. So I need to be wary of the environment, the structure of the organization, the organizational culture and politics. And this is one of the key issues in technology. As you bring in technology, some people might resist. People are used to certain way of doing things. Sometimes it might be difficult to bring in new technology, considering the existing organizational culture. I've seen some organizations sometimes even lay off workers as a result of resistance to technology, or because of certain organizational cultures, which might make that employee not able to cope up with new changes, which sometimes better to lay off those people who might not be able to support the new systems or the new technology that is coming in. So you need, again, to be able to balance culture and politics, the type of organizations and its style of leadership. You also need to take consideration of interest groups affected by the system, attitude of workers who will be using the system. So you need to do attitude management. I don't know how. So you need to balance on how you are going to make sure that workers are able to embrace the new technology. So the kind of tasks, decisions, and business processes that the IS is designed to assist. So you need to know exactly what this IS is going to bring, what tasks is it going to address. You also need to look into decisions and business processes that the IS is designed to assist. So you need to put into consideration when you are planning a new IS. Now, acquiring something else on acquiring IS for organization. So there are many approaches towards which we can use to be able to acquire an IS for an organization. So new IS promote various degree of organizational change. So enabling organization to design their structure, core power relations, workflows, products, and services. Sometimes, when I'm bringing in something new, it has a different flow aside from the normal organizational structure. So you need to be able to ensure that the flow is not affected as such, because as soon as it affects the flow, it means that you need to redesign. So you need to take into consideration the organizational structure, scope, workflows, and products. So there are common methods used in acquiring IS. One is outsourcing. I can decide to outsource an organization, outside the organization, to be able to supply for me the information system required, especially when you don't have in-house technical expertise who can be able to develop the IS. Then it is advisable to outsource. For example, cloud. I've seen some organizations who want to host their documents or their resources or whatever that can be hosted within the cloud by developing their private cloud in-house, which sometimes I would say that it is better you outsource, since it leverages advantage of you're not required to have your hardware in-house. So it means that you are leveraged from worrying on hardware, worrying on maintenance, worrying on security, because that you can leave that organization that is giving you that service. So sometimes, especially if it is a new technology, it is advisable to outsource. There is also application service providers. You can bring in people who are experts to develop them in-house, other than outsourcing it completely. You can have a system development team, which I can say for a new technology, system development in-house might not be advisable as such. For example, the ERPs that we have in place today. I cannot just tell you today that we can just use the existing personnel to be able to develop an ERP system from scratch. It might not be very economical, considering it is a new technology, meaning that every other time you will be having challenges. So it is better to outsource in that regard. So there's an advantage for each and every aspect. For example, if I'm using in-house developers, that it means it's cheaper, because I'm using my staff to be able to come up with this system. So that part, if you're worrying about cost, then sometimes it's good to do in-house system development. So as such, so those ones are ways which you can acquire an IS for an organization. You can outsource, you can use application providers, or you can develop in-house. So I would not want to explain much on outsourcing. I've explained. So outsourcing is giving an outside service provider to be able to give you the system or acquiring from an outside service provider. So reasons for maybe unpacking and outsourcing is a desire to focus on business core activities. Sometimes you know your duty. For example, CTech University core business is education. So concentrate on providing education services other than now starting to come and build information system to facilitate these services you are offering. So I can say that organizations outsource as a result of being able to focus on the core business activity. For example, a very good example is cleaning services. Cleaning services in universities, sometimes I would see other universities have their own cleaning staff, others outsource. And I would say that outsourcing is better because so that it can allow you to focus on your core business activity other than starting to manage the same employee who is providing you the service. Increasing competition that demands cost savings. So with, with increased competition, it's better you outsource. Flexibility with respect to organization and structure and even aim. So let it not be destructive to your goals or objectives as an organization. So it's better you just outsource. So there are issues on what to outsource. Sometimes as an organization, you ought not to outsource everything. Yes, because there are key things which, for example, matters financial. Sometimes some organizations would not want to expose to other third outside parties. For example, if it is telecom companies, once someone knows your strategy beforehand, then if someone knows your next course of action, then he can use that as an advantage and be able to even implement that new incoming technology before you start moving into it. I saw a company, there's a company in Australia which was actually manufacturing these communication equipments that are used by soldiers in combat. So some CEO of the company went to a conference in China. So, and used a Wi-Fi in an hotel. So out of using that Wi-Fi, someone was able to, they were able to hack into the system and obtain the data, resulting into exposure of processes and the technology behind these very powerful communication equipments used in combat. So out of that, today, as we speak, China is one of the leading manufacturers of those combat equipments today, making rendering actually the company which was actually the sole owner of the technology out of the market. You see, so we can say that there are other things which you might not need to outsource, considering technology-wise and the other key aspects. So I would want to say that ITO, that's tasks usually performed by IT department, including system development, operation, system maintenance, data management, etc. Those ones can be, I would say, can be outsourced. PPO, business process functions beyond the IT department areas, which can also be outsourced, system and software development, data and voice, technology design, call center operation and support. Those ones are some of the areas that you can outsource. Now, let's talk about application service provider. You know what we mean by ASP? Those ones are people who provide us with service. whether the different types of services that we want. But in this regard, these are external organizations who provide access to application software, hardware over the internet to multiple customers. Normally, the fee charged by this application service provider might be based on a rental basis, which is subject to rental pricing model, or whichever service model payment that is adopted. There are many aspects about payment of these services provided by ASPs. Like, how do we pay for internet at the university? So ASPs or service providers, like most external source of software and hardware, relieve the organization of a burden of developing and even installing software and hardware. So it's the responsibility of that service provider to do those tasks. ASPs are accessed over the internet, and users only need a web browser and an inexpensive PC or internet appliance to obtain the ASP service. A very good example is cloud service. What you only need to access cloud storage is internet. So you just acquire the cloud from the cloud service provider. They give you a space where you can store your data, and you can now connect using your internet over a web browser. The last section is system development. So when I talk about in this aspect, system development involves identifying business requirements and developing an IS for an organization. So of course, you know that we need IS to be able to support day-to-day operations and decision-making process in an organization. So anyway, when I talk about system development, it starts from identifying requirements, what organization need, and all the way up to implementation of that system. So we'll be able to see and appreciate the system development in steps later on, of course. So typical reasons to initiate a system development project. Why come up with a system development project? The reason is, before I develop a system, I must be informed by issues like problems in existing system. I've already identified that there's a challenge in the new in the already old existing system. Then that prompts me to be able to come up with a new system, desire to exploit new opportunities. You have been told that 5G is coming, so that pushes you towards running into developing, taking advantage of new technology to develop new systems which can be able to now use 5G. The main key thing is increasing competition. Because of challenges in competition, you see people are now adopting technology. And it is the same thing. Why people are now adopting online learning. Others have gone, people are in e-learning. So you don't need to be left behind by competition. Because people are moving away from traditional classrooms. So if you don't adopt online learning, because people want flexibility. So with increasing competition, you are forced to be able to adopt new technology or develop new systems. Desire to make more effective use of information, that's another key issue. Organizational growth. For you to be able to grow, then you need to stretch your ends. Make sure that you adopt technology to be able to, for faster production and even maximization of platforms. Other users want face-to-face, others want to use technology like that. That is why you even see organizations like telecoms, Safaricom, and you can see that today they have Safaricom self-care. You don't need to go physically to be able to get same services. So as a form of organizational growth, you can see people and coming in with new systems, or that pushes organizations towards the need to develop new systems. mergers or acquisitions, change in market or external environment. Remember the same issues about Porter's 5 forces model is pushing again these people to be able to develop new systems. So perceptions of potential benefit by individual capable of initiating change, like that system development process is initiated out of the perceptions of these key aspects, considering what are your issues, what are your problems, what are your competitors doing, what is happening outside the environment. That pushes you to be able now to do system development. That is it. So there are a number of theories of system development which are agreed that we are going to cover on system development approaches. So there are many theories to develop systems. Some of these are traditional approach, RAD, rapid application development. There is structured approach, or object-oriented development approach, and end-user computing. So I'll make an overview. Traditional, as it is a technology or an approach whereby you want to put in a new technology without following formally accepted steps. So the method relies mostly on skills and experience of system implementers or developers. So the next one is rapid application development. And I can agree with you today that there is no traditional approach of documented, or there is no use of a traditional approach in system development. No one uses traditional approach anymore, considering that we have new approaches to system development, like one is RAD, which is one of the commonly used approaches, which relies on information technology of computers. This is because there is a need for business or organizations to develop and implement IS quickly enough for them to maintain a competitive advantage in the market. And that is a reality. The way organizations or 21st century organizations develop or integrate technologies very fast. So with that, it means that you need rapid application development approach, where you are coming in with developers, a number of developers, to be able to do faster production of software. So advantages of RAD is ensures faster development of IS, and as a result, increased production of an organization. But key drawback of this is the working system may be weak due to quick development, because you are keeping pace with technology. You want to move very fast. So you pray that whatever system or developed model would look or would perform before commercialization, you hope that it can achieve what is entailed to, or meet the objective or intended goal, considering that there is no time. So you need the development team to move very fast. So for example, in a telco market or environment, you realize that competition is moving very fast. So there is no room to be able to look back or be able to concentrate on coming up with a system. You don't have a leverage of time. So you are moving very fast. So sometimes these systems might not work as it is. So there are challenges into it, even drawbacks of security. Later on, we'll be looking at aspects about IS security. So there are different approaches and techniques used in RAD, such as prototyping, joint application development, and a small team with advanced tools. So when I say prototype, I mean putting together a working model or a prototype of how a real system will work. Then you can now interact with the prototype. You can use that prototype as a forecast of how a real system will be working in a production environment. So a prototype is very is encouraged, especially when you want to see what are the features that you are envisioning in a real commercialable system before you move to commercialize your system or have it in a working environment, you just have an opportunity to interact with the prototype before. So prototyping is very, very important as one form of RAD. So why prototyping? There are many reasons as to why, which you have explained. Advantages and disadvantages, you can check on that. Joint application development is another approach. JAD uses highly organized and intensive workshops, bringing together system owners, users, analysts, designers, builders. You see, even those customers are part of this JAD team, you see. So JAD is a trained, what actually JAD team entails a trained system analyst who plays the role of facilitator for the workshop, trying to accommodate the views of all these people or stakeholders. Or as you are developing the system, you have all these people on board, you see. It's not like in prototyping, which we are talking about quick production, coming up with an initial prototype, test the prototype, let people interact with it. But for this one, working with all the stakeholders involved. Yes. So the role of system analyst is to lead this JAD team. There's the other one, small teams with advanced tools, which I can say it's a small team for JAD and uses computer-aided software engineering tools or case tools. So the tools generate reports, program codes, and documentations automatically. So you should be able to read. There is also structured approach. I hope we are still together, please. Before I continue, are we still together? Yes, class. Yes. If we are still together.
The screen is still at the first slide.
In your class. Okay. Yes. You are telling me you are in the last slide, please.
The first one, the screen.
Hi, what do you mean? So you are not following the notes? Yes. Let me unshare and try sharing again. Yes. Share again. I don't know whether you are. Are you seeing the slide where I am at the moment? Structured approach. Are we together on structured approach? Let me know. Yes, Catherine.
Mine is still on the first page, maybe.
There are no changes.
I don't know about the rest.
I think these other people are not in class the way it is.
Okay, the slide is still on the first slide.
Yes.
Okay, now it's moving.
It's okay now.
It is.
If it is okay, I can now proceed.
It's okay now. It's okay now.
Okay, I can now proceed. I was talking about structured approach. As the name suggests, structured, it means formalized. So there is a formalized, defined set of stages to be followed when developing a system. So when we talk about structured approach to system development, you just understand that this is a system approach which is well documented, specifying the activities to be carried out by system analysts and this team while developing a system. So there's a formalized approach. Now, this structured approach has steps. These steps are what we would regard as a system development life cycle. So the system development life cycle is factoring or having to appreciate the lifetime of an IS in stages. And normally SDLC has two broad categories: the system development and system operation and maintenance, just as a summary. But this diagram here appreciates the whole process. So, but just understand that in general, I can say system development, system operation, and maintenance. So SDLC, or system development life cycle, starts with preliminary investigation, where you are looking at issues of current system. What is the challenge in the current system before going in to develop a new system altogether? And that is where we are doing feasibility study. That is in stage 1, preliminary investigation. Then we move to analysis, where we gather data, analyze data, and develop requirements. Remember, we are trying to analyze whatever we gathered during preliminary investigation, where you went to users of current users of the system, trying to get their challenges. You now analyze the data gathered from that feasibility study in analysis stage. After you have analyzed, you can now transform whatever you have gathered into a design, where you generally have an initial preliminary design, eventually now do a detailed design, which can be transformed into an architectural model. So once I have done the designing of the system, I now move to development, which in realizing the system, you are just following, guided by the design or the model as an output from the system design stage. You now put in scheduling, how each of these modules will be implemented in terms of time, which should be started, which we should finish, as soon as which module finishes, which starts, like that. Then you move to programming and finally testing. So it means that you have now the system. Once you have the system, you now do implementation in the organization. So in implementing the system, you need a number of issues like training. You need to manage on user perception about the system. So you also need to do conversion. There are strategies being followed when you're implementing a new system, which we later on see again, up to including evaluation and overall maintenance. Because once the new system is there, you need to be able to maintain overall. So I hope you have appreciated the SDLC, starting from problem investigation, analysis, design, development, and implementation. So having seen that, these are the stages, which I don't want to repeat: system analysis, system design, development, and up to implementation. Maybe you only need to appreciate on the different types of testing, software testing. So we have alpha, where software tester tests whether it meets the design specification. Beta testing is users, you are using the users. In other terms, beta testing is users, alpha testing is developers themselves. Unit testing verifies that individual program units work. System testing determines all program units work together as planned. Volume testing uses real data. You know, sometimes you need to do load balancing and ensure that after how much data that this model or this system can handle. That's why you normally, once you acquire a system, you are told that this can only support up to maybe 100,000 users. So that is after subjecting it to volume testing, knowing how much it can handle. Load testing to determine if system can handle large number of concurrent users at the same time. So those ones are testing approaches, then implementation. So in implementation, we have agreed, you do training and the others. Now, a key area to check is system conversion. As part of system implementation, we have system conversion, and we have approaches to system conversion. This is parallel, direct, phased, and pilot. Parallel approach is whereby I have come in with a new implemented system, and you don't need to just jump into the new system. So you let the new system work in parallel with the already existing system within the organization, so that you are seeing the performance of this new system. That is what we mean by parallel conversion. Direct conversion is you stop the working system, the currently working system, and straight away use the new system. Phased is whereby you introduce in phases. You introduce the new system in phases. For example, if it is about student management system, you start maybe with student admission. You only work on that bit only. That is what we mean by phased. There is also pilot. You let users just use it first before and let them experience the system. You do piloting first before you now come in to commercially use the system. So it's very important to appreciate on system conversion and take note on parallel, direct, phased, and pilot. In fact, there's a diagrammatic representation there which tries to summarize on the same. So those are methods of maintenance, corrective maintenance. We can have adaptive maintenance of the system, perfective or preventive. So you can easily read on those. So there is also end user development, system development and programming undertaken by non-IS staff. So it's good to just appreciate that though conventionally, I can just say that in a real world scenario, these are very, very little or at a few instances, we can have the end users themselves to develop the system. So this is about IS being developed by end users with little or no knowledge on formal or any form of assistance from technical experts. Normally, they use tools such as MS Access. And I know Microsoft Access is one of exploratory type of database, I can say that, which comes in with the Microsoft Office package. So you can see maybe it's for those small systems which are not serious as such. But if you are talking about serious system, you are talking about developing it using Oracle database and even MySQL and the others. So that this is typical end user development applications, EUD and the risks posing it. And we can agree with end user the development is that inefficient use of IS resources. There is loss of data integrity challenge which can arise. There's high organizational risk, poor IS management and control, can be poorly designed, developed, and documented. We can agree with that. So that is it. There is also an aspect, factors that will lead to unsuccessful system development. Very, very important. There is lack of top management support. If there is no management support, top management support in any development of a project, that project might suffer from maybe resourcing and even factors like being able to support entirely the project. Because if top management would not want to put much into that project, it becomes a challenge. There's also resistance to change, where generally there's a natural resistance to change within organizations, where if I introduce a new system, you realize that employees might react negatively to it because they are used to a certain norm, even if it is a system which was not putting or having a competitive edge over the others, but people are used to that system, they tend to resist. They tend to resist because they fear to adapt to new technology, or they fear change. They fear learning that are the gap. So that is it. You need to understand the limits of IS and technology, and that. Now, I wanted to start just a little bit on this IS security. I hope I can finish this IS security or information security control. So I'll just go quickly over it, because I know you understand security. So it's just about reminding you. So IS security is all about sense of assurance that IS risks and controls are in balance. That's what we do in information security, making sure that risks and controls are in balance. So information security is three key things. It is all about confidentiality, integrity, and availability. So as soon as you come across information security, just take note that we are interested in making sure there is confidentiality, integrity, and availability. So if someone would ask you what is information security, you should be able to know that IS security is CIA, ensuring CIA. So you can be able to read those other things. So security cuts across multiple layers. Just to take note, we need to be able to appreciate security considering the physical aspects of security. The building, securing the building where the IS is for example, the servers in a server room, which should be secured with a padlock, that is physical security. There's also personal security, operation security, communication security, ensuring that data is encrypted end to end, which also cuts across to aspects about network security and information security in general. So you need to get the different aspects of security. Remember I said IS security is about CIA. That is why it's a common triangle in security known as CIA triangle or CIA triad, which tries to map security in three aspects. But in general, the components that makes up IS is network security, computer and data security, management of IS security, so that all these ones are guided by the policy. There is a security policy within an organization. I don't know whether we have an IS security policy within CITEC University, I don't know. But you know, you need to know that in any organization, there is, I must agree that there must be a policy guiding on use of IS and IS resources, which also need to extend much on policy or information security policy. That is why you can see a number of organizations are being pushed towards ensuring that they have compliance or subscribe to ISO 27001:2013 standard, which is a standard or a guiding framework for IS security for modern day organizations. I think you must have seen that there is an ISO 9001, I think 9001:2013 or 2014. Who is versed with that? The latest for organizational management. So also we have organizational security management, just similar to that ISO we'll talk about for your organization management. There is ISO for security, and that is ISO ISMS 2007-2013, the latest one. So which guides organizations on implementing security. So you need to be able to balance IS and access. You can read those ones. Reasons for controlling IS systems. You need to guard systems against hardware, software, disasters, and those other things. So you need to read that, general controls and application. So measures, it can be preventive, it can be detective measures, corrective measures, deterrence, like that. So there is also time-based model of security, which is interplay, coming up with variables considering three aspects. That is the time it takes an attacker to break into through the organizational preventive control, time taken to detect the attack, time to respond to attack. So these three variables are evaluated so that you can talk about preventive, meaning that time is an interplay of time it takes to attack and time it takes to respond. So preventive should be greater than, it should be greater than time to detect and time to respond. That's what that is what this time-based model of security is based on. So you can be able to check on that. So in general, as I've covered on IS security, in general, issues about information system and information technology, you need to ensure that in case there is a disaster, in case there is a security situation bringing down the whole IT infrastructure, you need to ensure that at the end of the day, there is a strategy in place known as disaster recovery and business continuity. In case there is a disaster, you need to be able to continue providing business as usual. So you need to be able to plan for continuity in case or after a disaster has happened. Then you need to be able to plan for continuity. That is what we talk about in disaster recovery and business continuity. And you must be having that strategy within your organization. So like how you're going to ensure backups. You ensure backup as a result of, as a strategy for recovery. Why I have backup is so that I can be able to recover in case of a disaster and be able to continue as usual. That's why we say DR and BC, disaster recovery and business continuity. So this is an example of a layered security approach, technologies and tools used for security and control. So in any, I just wanted you to just appreciate an overview of how we implement IS security within any organization. For any organization, one, you are connected through the internet. Even in CITEC University, that is how it is. We are connected to the internet. Yes. So once we are connected to the internet, the first thing you need is a firewall. Before, I want you to take a scenario that you are connected your device from a LAN, which is inside the organization. So within the organization, the first thing is you are connected to servers, which are now corporate systems, and even the database. All these ones are organizational systems that you want to access. So before to access this, remember you're accessing it using a network. So the first thing you need is an inner firewall, which we configure rules governing on access. You see, of course, being defined by the policy rules. They are given policy rules that are defined within the firewall, both inner and outer firewall. Another system is web server. You see now that web server is somehow one of the exposed system resources within an organization, because this web server should be accessed by outsiders. So that is why it is placed outside this inner firewall. The only thing that can protect is this outer firewall, but not as such, because sometimes this is one of the key points of attack to any organization because of the exposure. In as much as you configure the rules, sometimes it might not as such be able to protect this web service. So anyway, I just wanted you to appreciate a layered approach to security so that you know where systems are placed as such. So these are best practices you can read on your own. Best practices for firewall. Best practices need for information security professionals. Like that. Challenges. Maybe just summarize, because this is the answer, the last slide. We need to agree that the sophistication of information security attacks has gone up so much, and it is an upward trend compared to the speed at which technology professionals are coming in to be able to put in the necessary measures. So the speed at which people adopt technology is very high, considering the speed at which they are worrying about security. So one key challenge is speed of attacks, sophistication of attacks, faster detection of weaknesses, and there's also distributed attacks, considering the rate at which the internet has grown, has promoted aspects about distributed attacks, also prompting us into how are we going to aware people? How are we going to move in speed to bring in technology to be able to control these distributed attacks? And even difficult of patching. When I talk about patching, I mean being able to correct bugs. You know, I talk about bugs as errors in systems, or software developed. We have developed a software system so that there are issues that need to be updated. Those issues that needs to be updated, or bugs which needs to be updated, are what we term as patching, correcting those errors. So all those ones are challenges facing that we have facing information systems and security-wise challenge. And we have agreed that the rate at which attacks are launched or are facing information system is at a higher trend compared to how securing it, or people securing it are coming in to be able to protect these systems. And you just need to understand generally that the biggest challenge in security is human aspect. The human aspect of security is a challenge, because those ones are the same people who are acting as corridor of attacks, the same people who don't want to configure passwords, the same people who like to assume things are the ones who actually acts as a point of facilitating these security issues. So that is it. I think I've moved so fast, but in the next class, I hope you have the notes to read it, so that in the next session, I will be able to start from the next ask for competitive advantage. So that is it.